Hello everyone, March 23rd. Alright, new day, new challenge. Well, we didn't do very well yesterday, so I hope today we can vengeance what we had yesterday. Let's first take a look, as usual. I remember this is what I did yesterday. Did I say anything? Yeah, I think I did say something. Yes, I remember I said something. What else? Nothing else of concern. Let's see. I think I commented here, but nobody has responded, which is fine. Totally fine. All right, let's take a look what we have today. Threesome with multiplicity. No, multiplicity. All right, it's gonna be three sums. So three. I've done two sums. Yeah, now it's three sums. I forgot how to do two sums. Anyway, given an integer array, okay, and an integer target, so we have a target, return the number of tuples such that, okay, and they add together equals target. What does it mean, multiplicity? I don't know what that means, so. Anyway, let's take a look. So the first one is 8. So it has to be 1, 2, 5 occurs 8 times. What does that mean, occurs 8 times? A number of tuples, okay. Oh, I thought that was the value. No, that's index. So 1, 2, 5, 2, 2, 2, 8 times. 1, 3, 4, 2, 2, 2, 8 times. 2, 2, 4, 2 times. 2, 3, 3, 2 times. That's 20. Okay. So this one, 1, 2, 2 occurs 1, 2, 2. So this will be C 4, 4, 4, 4, choose 2. 4 choose 2 is what? 4 choose 2 is 4 times 3 divided by 2 is 6, and then times 2 is 12, exactly. And, oh, okay, that's it. Okay, so we have 3,000 and target. All right. So apparently we need to do a counter, right? We do a counter so we get the actual non-repeating value out. So let's take a look at the first example. So if we do a counter, it'll be 1 is 2, 2 is 2, 3 is 2, 4 is 2, and 5 is 2. Okay. So next, we need to know, because it's three sums. So basically we have to fix one number and look for another number. Oh, hold on. Hold on. It says IJK has to follow this, which means if we use, change the order of this, let's try this one. If we change the order of this one, it's going to be 5. So instead of doing this, we then do this. All right, I think the number will reduce because, no, it's still, it doesn't matter. It doesn't matter. It could just be a 1, this, and this. Okay, so the order doesn't matter. Wait, does the order matter? The order welcomes you. Anyway, okay, so the order, it will matter which means if it matters, which means in one order if it works, and if no, it does not. It does not matter. The order does not matter because we basically just saying Yeah, I think this is a bit like distracting. Basically, just saying, given this, right? I want to pick three numbers. We pick any three numbers because any three numbers you pick will follow this, right? Any three numbers will follow this, so it doesn't really matter. Okay, so this is basically just to confuse you, right? We don't have to think about it. So the question is basically the number of different ways to pick three values, to pick three indices that can result in a sum to be equal to the target. Okay, so we have simplified the problem a little bit. We remove a little bit the distraction. So now we can do counter. So right, we do counter, and then we say our target value is 8, right? So we look at the first value. We can even sort it, right? We can even sort it. So we can look at the first value is 1. So we know we need 7. Now we can do the first value again. That's 1. So the first level, we do 1. Second level, we do 1 again. And then third level, we need a 5. Now we find a 5. Now, after we do that, we need to see. So after we do that, we say we pick 5, right? So we have 1, 1, 5. And then we need to determine how many different combinations we can do. 1, 1, 5. Oh, 1, 1, 5 is not right. 1, 1 has to be 6. So 1, 1 is not correct. So that's it. No 1, 1. So we can do 1, 2. Right? 1, 2. We need 5. So we have 1, 2, 5. Right? So 1, 2, 5 is good. How do we determine? So 1, 2, 5 is good. So we're going to look at 1. How many 1s we have? We have 2 1s, so it's 2. 2, I have 2 2s, 2 times 2, and then 2, so that's 8 different combinations. Now moving on, we're going to do 3, 1, 3. 1, 3, we need a 4. So that's the same thing, so it's going to be 8. Next one is 1, 4. 1, 4, we need 3. Hold on. So this is where we stop because we already considered that, right? So we stop. So 1 plus 3 is 4, right? So we're gonna stop right there. Do not continue because continue will be the same. So we do not continue. So for 1, we're considering to 3. Next, go back to the first level. We're gonna do 2. So 2 has to be either by itself. So we'll get 2, and that's 4. And we can't have a 4. Now we're going to see we have 2, but 2 2s already. So the remaining, so basically, oh, it's C. Yes, it's a C2 2. This is 1 times 2, so it's going to be 2. So that's have 2. And then next one, because 2 plus 2 is already 4, is a half of 8. So if we do 2 and 3, that is not going to work, right? Actually, no, we can do 2 and 3. If we do 2 and 3, that's 5. So we need a 3. But that one can come when we do 3. So no, we stop right here. We stop when we hit more than half. Because if we do one more, the value will be smaller and it will be encountered previously. So 2 is done. So just 2 do 4. Now we do 3. 3, 3, 2. Right? Same thing. It's going to be 2 chances. Now we're going to do 4. 4 is only 4, but it's already 3, 3. You know what? 3, 3. You're not supposed to do it because 3, 3 is larger than 4. How do I avoid repeats? Well, if it's 3, and then the second value I say can only be 3 or larger, so we do 3. And the question is, it shall be done already in the 2, right? Which means I have to do 2, 3, 3. But if we do 2, 3, that is going to be 5 as larger than 4. So we have to keep going, but just check. Yeah, we put that in like considered as a tuple in a set to check whether we have encountered this already. Yeah, we can set up a set, right? A set, and just put all the pairs, all the tuples we've found into the set, so we know which one we've done, which one we have not done. So let's just go through everything. So we're gonna go through 1 1 1 2 1 3 1 4, and 1 4 will have 1 4 3, and we realize this one we already done, so we skip. And then 1 5 gonna be 1 5 2, we skip, and that's it. Ooh, but that way we'll have to iterate through all of them, 3,000 of them. Is that the best way to go? We iterate through every single one? It shouldn't be, because we'll say that it's already considered. But then we have the 2 2 4, and then the 2 3 2, 2 3 3, right? We can argue that 2 3 3. How do we evaluate 2 3 3? Well, the way we evaluate it is we do 3, and then we check the remaining number. Yeah, I think that's how we check, right? 2 3 3. I mean, if we do 2 4, then we are going back. So we should keep going until we hit something that we've done before, and then we stop. Yeah, that sounds more likely. That sounds more reasonable. So we're gonna do 1 1 5. No, 1 1. That's not good. 1 2 5. That's good. 1 3 4. That's good. We're gonna do 1 4 3. But 1 4 3, we see that it has been done already. Now we know we are going to repeat. So we stop right there. For 2, we do 2 2 4, and then we keep going 2 3 3. That's good, which gives us 2 different varieties as well. And then we keep looking. It's 2 4, 2 4 2, and then we see 2 4 2. We have done that already, so we skip. Next, we're gonna go 3, and then we have 3 3 2. Then we see it's been done already. We skip, and then that means we just skip completely. And then we go 4, and then we see it's 4 4 is already bad, and then we just skip completely. So we don't do any more. So we have 8 8 2 2, 8 8 2 2. Yep. Let's code it. Let's code it. I think we're on to something. We're on to something. So let's try it out. It's not gonna be like ON. I think it's definitely ON squared. 3,000 ON squared. I think we can squeeze it in. Yeah, because yesterday it failed, because yesterday we have 5,000. Now 5,000 ON squared is not going to work. But I think 5,000 ON log n is going to work. And if it's 10,000, probably ON log n is not going to work either. So it has to be like ON. Anyway, so here's the plan. We need to have Does Python has like math? Python permutation. I don't know. Oh, have combination. This is what we want. Math.com, which is choose k from n. Okay, so that's what we need. So we're gonna have math. Import math. We're gonna start with what? Start with a for loop. No, start with a counter. Start with a counter. So we're gonna from collections import counter. Then we're gonna say counter equals counter array. All right, and then we're gonna say what shall we say? Shall we say vowels? All possible vowels gonna equal to counter dot keys, and I want to sort it. All right, so this is the vowel, and then we're gonna say for I in range. Actually, it's gonna be for I v in enumerate. That's the first level. That's the first level, and then we're gonna say for j in range I to len vowels, right? So that's the second level, and we're gonna do if target. No, first check is if. Let's do A, B. A, B equals vowels I and vowels J, right? So the first two value, and let's put some check on it. So the check is if A plus B is larger or equal to target, then we're gonna break. All right, that's the first check. Second check is if we actually can have C as well. Let's put C here. So C gonna be target minus vowels I minus vowels J, right? So it's going to be if C is smaller or equal to 0, we're gonna break. Now, if C in counter and no, next one is if A, B, C. Oh, it's gonna be a set. If set can be like this: A, B, C. Set can be, yeah, I think set is hashable. So we say A equals a set, B equals set 1, 2, 3, and I say A dot add B. I think this is addable. Unhashable. Set is not hashable. Oh, doesn't matter. Does not matter. Because the way we are doing this, the third value has to be, yeah, this actually is a better way to tell. The third, if C is smaller than 0, or C is smaller than B, right? Because A, B, C, the way we're doing it is going to be small, medium, and big. It can be equal, but if C is smaller, then we're just going to break. All right? Yes. Now, if C is smaller, then we're going to break. And then, if C in counter, then we're going to have a rest. We do not break if C is not in counter because it's possible. So if C in counter, then we're going to say Oof. Then we're gonna check. How do we check? So we're gonna check. Huh. Let me think. We need to know whether A, B, and C, any of these are equal, right? So we say if A and B is equal, so the only possibility is A and B is equal, or B and C is equal, or A, B, C, 3, all of them are equal, right? That's the only possibility. Like if A and C is equal, then B must also be equal to them. So what we're going to say is if, so the only possibility is if A is equal to B and B is not equal to C, then res plus equal com math.com, is that COMB? Yes, COMB, math.com, and then we're going to be choose 2, right? So who choose 2? Counter A choose 2 times counter C. If A not equal to B and B equal to C, and then this one will be B and then A. If A equals to B, A equal to C, which means all three are the same, and res plus equal to math dot combination counter anyone and then do 3. Else, that's they all not equal. None of them is equal to anybody else. We counter A times counter B times counter C. Yeah, if C is not in counter, we go it again. And if C is smaller than 0, that means we have too big on A and B, so we break it. And next is the same. If C is smaller, and then we're going to break. And we can also go it a little bit shorter if we know, right? Let's see. We immediately break. We can actually break it faster, right? We can break it faster if the value is larger than half of the target. Then we know the scheme is not going to work. So what we're going to do is we're going to set A here. Let's set A here, right? A equals to val I, and then BC equals this. This is going to be minus A. Oh, I have V. Oh, wait, let's do A. It's right here. It's right here. So I'm going to say if A is larger than target divided by 2. All right, if A is larger than that, then we just break. We don't have to keep going. And eventually we're going to return vowels and then do 10 to the 9th plus 7. Actually, let's just write it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so that is our solution. Let's take a look. We have 2 test cases for us to play around. We'll see if both work. That's the first one. The second one, 1, 1, 2, 2, 2, 2. Right, and then we're gonna get 5. And the first one, the result is 20. Second one, the result is 12. And let's deal with all the commas. Oh, come on, man. All right, and here I'm gonna say array target. Change this to 3-sum multi, which I'm gonna call array and target. Run it. I have a syntax error here. I have syntax error everywhere. Run it. Unsupported operation. Oh, why do you say wow? This is res. All right, both pass. Let's try it. Submit. Pending. Judging. Wrong answer. Man, we've been doing wrong answer very often lately. Like really, really often. I actually don't know. I have no clue. I guess. Let's try this one again with a slightly different value and then see how we get. So we're gonna have this. Let's put 0 in it, right? Let's put 0 in it. Hold on. I want to refresh this so I won't be able to see the wrong answer. As it's very tempting to see the wrong answer and to debug based on the wrong answer, which is not the right way of doing things. So let's put 3 for each one of them to make it like juicier. And we're gonna put we'll also put a 0. So we're gonna just do, let's say do 1, right? Let's see if we got the right answer. Okay, 1 is the right answer. We do 0. How about 0? 0 give us fail because we did it too fast. So we're gonna wait, try it again. 0 shall give us 3. And not 3. 0 shall give us 1, but we only get 0. All right, we found something. So this, if we do 0, shall give us 1, but we are returning only 0. Why is that? Okay, so same thing. 0 is larger than target divided by 2. So our target is 0. Oh, so are you talking about equal? Equal is still not right. So that's not the issue. I mean, if it's larger, then we're going to escape immediately. So now we're larger than equal to, at least we get inside, right? And then we say B is starting, so B should be 0 as well, and C is 0. And I say if C is smaller or equal to 0, we have to do, okay, the 0 is a troublesome thing, right? 0 is troublesome. 0 is very troublesome. Okay. Because I can see that if we do 8, I'm going to be wrong as well. Because I will count. Oh, that's actually correct. Oh, yeah, it's all right. So it has to be this way, or we just do this, right? Why do you consider C smaller or equal to 0? It's going to be smaller than B anyway. All right. So C is 0. B is 0. This one actually doesn't go. So we go here, right? And C is in counter. And then we're going to go to A equal to C. So counter 0 is 3. Why we come out as 0? I do not understand. Let's try here. Let's just print counter. We did not go here. Oh, here we break it out. It has to be larger. Yeah. There we go. Now we pass. Yeah, I don't know why I did it the other way. Doesn't make any sense to me. Okay, so the change we have is quite minor. I think just to handle all the zero case. Okay, we're gonna run. This we can try like a different value. Not even sure if this one has any. 10. 0 should be correct. Okay, try it again. Submit. Pending. Accepted. We got it. Yeah, I think the special case is just the zeros. Once we handle the zero, it's all good. I mean, to handle the zero, honestly, it's just a little bit oversight over here. This case overlaps with c smaller or equal to 0. It doesn't really matter. Take a look at the runtime. Ooh, that's a good runtime. It's a good runtime. All right, so the idea of, first of all, we need to identify, to realize that the requirement on indices I, j, and k is just a distraction. We don't have to worry about that at all. Then the problem becomes how many ways there are to pick 3 numbers from array that sum up the target. Our solution is to fix the first and second value, the first and the second values, and examine whether a third value can be found in array. To make this process systemic, we first we convert the array into a counter. Thus, we have knowledge of the number of repeats each value has. Then, when we fix the first and second values, we make sure that it is done in an ascending order. This is to avoid computing repeated. How should I say it? This is to avoid computing. Avoid double counting. When we obtain the third value, since we are always iterating in an ascending order, if the third value does not follow the ascending order, well, I should also specify it's ascending or non-descending. That's the case. Make sure that it's done in a non-descending, non-descending order. All right, and say to obtain the third value, always turn it in a non-descending order. If the third value does not follow the order, we know that the current iteration is over. This saves us time to not go through everything, not go through all the values. This allows us to stop. This allows us early stop. Similarly, we can do early stop with the first value as well. If the first value is larger than half of the target, it is guaranteed that with our scheme, no solution will be found. Overall, this is O(n) squared. I think it's pretty straightforward. 2 for loops, O(n) squared, and we run it at 72 milliseconds, and we surprisingly get a 92% ranking. So with this, I declare that our fiasco from yesterday has been vengeance, which made me happy. Okay. All right, now let's take a look at the solution. This is a medium question, definitely. It's a typical, normal, medium question. Let's look at the solution. To sum, 3 pointers, counting cases, adapt from 3 sum. We have 3 different solutions. We'll take a look at all of them. The people asking, the indices doesn't matter. Yeah, indices doesn't matter. All right, let's see. What's the first one? 3 pointers. We saw the array. Yeah, like I already said, right? It doesn't really matter on the it doesn't matter on the what when I think on the order. We can sort it, and we have 3 pointers. Basically, have the first one, second one, and third one. They all point on the first one, and the second and third start moving, and the third one move, and then they will find a solution, and the third one keeps moving until it cannot move anymore. Like we count all of them, and then what? And then we move the second pointer, third pointer coming back to the second one, and we do this again. I think that's probably how it is going. Let's see. To sum with the multiplicity. So we have a t, the target minus this, j and k. So j is, k is, k from the end. Okay. And then they're trying to merge, coming together. And we say if they're too small, j increment. If they're bigger, k decrement. If it's equal, right? And then we say if they're not equal, which means these two plus the sum equals t, but they're not equal, then let's count left. The number, so we're gonna count left, we're gonna count right, and then we contribute this one, right, that's correct, and then j plus 1, k minus 1, that's correct. This is when they're equal, and if they're equal, that's the first time they're equal, so we count the number n times divided by 2. Okay, yep, that's good solution. I like mine. I won't implement this one, but I see what this is doing. This is good. This is good. Second one, counting cases. That's exactly this one, right? Let's take a look. Is the maximum possible value of AI. Oh yeah, it's actually not n squared. It's actually smaller than n squared. We do a counter. What is 101? What is this 101? Oh, it has like on the values? Oh yeah, okay, on the values. Oh yeah, this is just okay, just a counter. So we're looking for all x, looking for all y, and z is this. Ah, I see what you're doing there. Right? And then z can be all different. So z equals this. If y smaller than z, smaller equal to this. Why do you have to do? Yeah, yes, we have to do. Good. X equal to y. Then z is this. Okay. This is y equal to z. Y equal to z. So x by itself, the remaining. And if this, good. If let's put a little bigger. If if this equal to 0, which means target can be divided by 3, x equals this. If this, okay, good one. How about this one? Oh, look at this. What do we have? This is similar, but still, yeah, it means the same. I am iterating from the start. They are iterating from both ends, right? Same, else, and then we're gonna do if else is everything. Oh, I have a different. That's slightly different. They do. What did they do? IJK. Huh. I doubt it actually. XY equals this. How is I equals J? No, this should be XYZ. XY, this should be XYZ. How is I equals J? How is this IJK? IJKs are index, right? They're just index. They are just index. What are you saying? What you're saying is, what are you saying? If these two that are keys J, keys K, right? Yeah, this is just the front and end, right? And then, oh, okay. Yeah, it's the same thing. Same thing. IJK, it's sorted. It's nah, I don't think this is as good as using XYZ directly. It's the same because they're based on keys, which is a sorted, right? Which is sorted. So the IJK, they're in the same order as XYZ. So yeah, this is basically my solution, just slightly different, right? Slightly different. They use a conversion from the second half, right? We have J and K, and they start from the front and the back of the array, and then we go into the middle, kind of looking for possibilities. And for me, it's always going from the front. We're going from front, and then we do a check. Right? We do a check. So it's the same. I am not going to implement any of these because I like my solution. I think my solution is good. Yeah, I mean, they're basically the same, right? They're basically the same. They're basically same thing, just written in a fancier way. All right. Combinations with replacement. Huh. Okay. Okay. That's a good use of combinations with replacement. That's good use. Combination with replacement. Let me see. LeetCode has combination with replacement. I do not know. Oh wow, combination with replacement. Nice. Nice. Yes, that's basically what it is. And we know it's the maximum is what? It's like C is 3000. So C 3000 choose 2. Right? But with replacement, that still could be a gigantic number though. Huh. Ten lines, super easy. Knapsack. Oh, oof. These people are getting deep. Combinations. Permutations. Permutations. Yep. Permutations. So this is when they're all not the same. Okay. That's actually good. And then this is when they're all the same. And this is okay, this is they're all not the same. This is they're all the same. No, this is they're all the same. Right? This is they're all the same. And then this is two of them are the same. How do you know which two are the same? For I and C, 3i is not equal to target. And then we say if 3 times I is not equal to target, so we say that it has to be either I something, or I something, or I something something, right? So we say it's going to be CI times, let's say it's I something. Yes, that's true. It could be I something because we iterate through all. I mean, this is the difference, right? So that when they're solving this, they consider the entire thing, right? They don't really pick and choose. When I solve it this way, I actually pick and choose. Like I make sure that all of my values are following the non-descending order. But they don't really do that. And then they are using the fact that if there's a value that a counter doesn't contain, then it will return 0, right? So they make their code shorter, but I basically check it, right? I'm like this is like two ideas, right? My idea is look before you leap, and their idea is to ask for permission. No, wait, what's that? Ask for permission later, and the permission is not going to throw an error. Permission is just going to give you 0. But I like this thinking. I really like this thinking, right? Same with the Leet 215 solution. we just go through all combinations, blast through all of them, and then just analyze it after. All right, good, pretty good. No tengo ganas implementar los otros soluciones. Eso es bueno para mí, suficiente para mí. All right, we vengeance from yesterday, and that's it. Oh, shoot, I need to see which one it is. Ha, I forgot to write that down. But anyway, that will be it for today. I will see you guys tomorrow. Adios.